Hi, welcome to the next video. Today we are gonna learn a bit about the last of the climate elements, which are the atmospheric pressure and a minor one, which is wind. But the atmospheric pressure is pretty important. You know it's gonna be tougher than understanding temperatures and precipitations. Those two are pretty straightforward. The atmospheric pressure is a bit more abstract, but I'm sure that with patience and reviewing the most difficult parts, you will get it. It's a short video, so that's it. Let's try to define what the atmospheric pressure is. We can define this concept, this element, as the weight of a column of air in an area. I know it's kind of difficult to interiorize to understand, but let me show you this graphic to make you understand. Air has weight actually, all right? That's why the atmospheric pressure is basically higher in a lower area than in a higher area, all right? So in this area the atmospheric pressure is higher, and in this area is lower. One way to understand this, or an easy way, is to think of the surface and a column of air. As you can see here, the column of air in this area, a lower area, is taller, right? Here in a mountain is shorter. It means that the atmospheric pressure, the pressure that the air uh, is uh, is making here in the surface of the mountain chain, is going to be minor than in this area. The column is larger, so the atmospheric pressure in this area here, it will be higher. Alright, the weight will be higher here than in mountain chain area. As I wrote here, depending on the weight, we know about high pressure areas. We are gonna call those high pressure areas as anticyclones, and low pressure areas, we are gonna call them cyclones. In Spanish, we got different names. The high pressure areas are more or less the same, anticiclones, but low pressure areas in weather forecast, they are called as borrascas. Anticiclones y borrascas. Anticyclones and cyclones. The major factors that affect the atmospheric pressure, in other words, how high the weight of the air is in a specific point, are basically altitude and temperature. To understand altitude is more or less the same. As altitude is higher, the atmospheric pressure is lower. Alright? So, greater altitude, less amount of air, so pressure is lower. Those columns of air, alright, think about infinite columns of air here, are shorter. So the pressure of this air is not as high as in a lower area. The second factor is temperature. Alright? Basically, warm air has less density, it's less dense than cold air. It means that as air being less dense, having less density, the pressure is also lower. Alright, let's give you a really quick example to understand the atmospheric pressure. As you may know, people who want to go hiking into the Himalayas, the Everest, the tallest mountain and mountain chain in the earth, when they are going to the higher areas of the Himalayas, they need to start using oxygen. Basically because in areas with really high altitude, the density of air is pretty low. So they need to use artificial oxygen, or they have to bring oxygen to be able to climb the mountain. In the Himalayas, in the top of the Everest, the atmospheric pressure is pretty low because the columns of air are shorter, and the density of air and oxygen is less than in a lower area. Alright? So again, cyclones, high pressure areas, low pressure areas, I'm sorry, anticyclones, high pressure areas, depending on the altitude and the temperature, among other minor factors. Alright, let's go through. In those low pressure and high pressure areas, they got pretty significant effects on the weather. If you remember, the weather is basically the temperature and climate and other minor elements, like for example the amount of clouds, or if there's fog in a specific time, like a day, an hour, a week. All right, it's not the same as climate. I'm sure you remember the differences between weather and climate. So the effects in the weather are different depending if we are on a high pressure time or a low pressure time, because atmospheric pressure tends to change a bit across time. Cyclones, as I said, or low pressure areas, they tend to cause unstable and rainy weather, right? Unstable, rainy weather. Basically because the air rises in low pressure areas. As air starts rising, it cools down, and then condensation process starts. Remember about how precipitation works. So yeah, anticyclones and cyclones, high pressure areas and low pressure areas. Careful here, because wind has is a major factor in atmospheric pressure. In areas with high atmospheric pressure, air tends to go down. All right, as the air is going down, as there's no elevation of air, condensation processes are not possible. All right, the air and water vapor is not rising. But in this case, with the cyclones or low pressure areas, the air tends to ascend, to rise. As the air ascends, starts cooling down, and then condensation and precipitation starts. That's why when there's a low pressure area in an area, it tends to rain, because the air tends to ascend, tends to rise. All right. The unit of measure are the millibars. All right. We can know that a cyclone or a low pressure area is in an area if it's below 1013 millibars. Alright, this is an arbitrary grading, so just stick with this number, 1013 millibars. On the other hand, the anticyclones or high pressure areas, they got the opposite effects of the cyclones. So in a high pressure area, they tend to cause stable and sunny weather. Basically because the process is just the opposite, alright? The high pressure areas, the air goes down instead of going up. So condensation processes is not possible, as I just explained. For precipitations to happen, the air has to go up. With the anticyclones or high pressure areas, the earth tends to go down. That's why those are sunny days versus cloudy days. All right, it's not related with temperatures. On the other hand, this could be a really cold winter day but sunny. All right, and this, for example, could be a really warm summer day but cloudy. All right, this is another example of how cyclones work. As they got low pressure areas, air tends to ascend. As he ascends, he cools down, starts condensating, and then precipitations happen. At the beginning of the lesson, I told you that you, ironically, know a bit about those high pressure areas and low pressure areas. Basically because I'm pretty sure that you have already watched a lot or just a few of those weather forecasts telling us if it's gonna rain, it's gonna be sunny, it's gonna a storm is gonna happen near where you live. All right, and basically the idea is as simple as I explained them to you. Those lines, all right, they are called isobars. They measure the atmospheric pressure. If you pay attention here, it is represented in millibars. As we said, 1013 is the number you want to remember. If they are below, alright, a cyclone is happening there. If they are above, an anticyclone is happening in this area. So for example, in this area of the northern Atlantic Sea, for example, there's an area of high pressure because millibars are 1020 millibars. So a high pressure area is happening here. It means that in this area, not a cloud on sight, no precipitations for now, obviously. On the other hand, let's go to the Iberian Peninsula. In the Iberian Peninsula, we got a massive cyclone or a low pressure area. As you can see here, is below 1013. It's below 1996 millibars. It means that in this area, the cyclone is going to cause precipitations. Alright? So expect in this area cloudy days, precipitations. Alright? Good. This situation is not going to remain like this eternally, right? So those high and low pressure areas are going to move around, and it's possible that in a week or in a couple of weeks this low pressure area move to another place, and high pressure area is affecting the Iberian Peninsula. Good. Let's finish this lesson with a couple of concepts. The first one is what we know as the atmospheric belts. Those are a complicated concept to understand. Basically, they are constant cyclones and anticyclones, constant low and high pressure areas located in an specific parts of the Earth. Typically, they are in the major parallels of the Earth, in the tropics and the equator. Alright, tropics and the equator. So in the Tropic of Cancer, there are some high pressure areas, and they are there constantly, alright, from the start and the end of the year. So they do not change. It means that in this area, always high pressure areas. If you pay attention, you could observe how in this area the Sahara Desert is placed. This is not random. The Sahara Desert is there because here in the Tropic of Cancer there's an anticyclonic belt. It means that as air is constantly moving down, precipitations cannot happen there. Alright? On this area, it's more or less the same. Alright? Another anticyclonic belt. The Kalahari Desert here and the Atacama Desert are located in this anticyclonic belt. On the other hand, the equator, there's a low pressure area belt. It means that in these areas, the air is constantly moving up, rising, which means that precipitation in those areas is pretty high. This is why the rainforest is located mostly here around this cyclonic belt. The only difference between the regular cyclones and anticyclones and those belts is that those belts, following the whole parallels of the Earth, they do not change across the year. They are always there. There's a low pressure belt in the equator and high pressure belts in the tropics. On the poles, on the other hand, also low pressure belts there. So here in the north and southern poles, low pressure belts happening there. Finally, let's finish this part talking about the last element of the climate, which is wind. As a definition, it's pretty simple. It can be defined as air in movement. The origin, careful about that, thank you. The origin is in the difference of temperature, of pressure. So why is wind happening? Basically because there's a difference in pressure and the air is moving from one point to another. They always move from high pressure areas to low pressure areas. So here the wind is going to move from north, a high pressure area, to the south, a low pressure area. So in this situation, wind will follow this direction. Here's another example, alright? to understand this. As this is a high pressure area, wind is going down, then wind is gonna move to a low pressure area, and then he will ascend. As he ascends in altitude, he will go back to a high pressure area. This cyclical movements is how wind works actually. Alright, and we are done for today. I hope I explained myself. Some activities from page 71. I want you to send it to me as well as the bullets, and I hope you understand. If you have any questions, please write to my email. Please do it instead of just having some doubts. I will answer them as soon as I can. Thanks so much. See you in the next video.